Good day, students. Today we are going to be looking at Dalton's law for partial pressure. Dalton's law for partial pressure. Now let's consider a vessel with a mixture of gases. Now the Dalton's law of partial pressure is not telling us that the total pressure of all these gases here, because it's not just one, we have different gases in this place, but they should be a form of a mixture, not reactive gases. Take note of that. Not reactive gases. There should be something like non-reactive gases. So the total pressure of all these non-reactive mixture of all these non-reactive gases will be equal to the sum of their respective or individual pressures. We call them partial pressure. The sum of their partial pressure is the pressure of the first gas plus the pressure of the second gas plus until you get to the pressure of the last gas. So that is Dalton's law for partial pressure. Now this law will hold for non-reactive gases. You know there are some gases you will combine, they will react to form a compound. So we are not talking about all those gases. So please take note of that. It's very, very important. So we also have what called mole fraction. Now mole fraction x, if we get s mole fraction, is just the pressure of a particular gas divided by the total pressure, or the volume of a particular gas divided by the total volume, or the number of mole of a particular gas divided by the total number of moles. So either use this or this. For the volume, we don't normally use that so well. So that is for mole fraction. Just take just say what is the mole fraction of this gas. Just take the partial pressure of the gas divided by the total pressure, or take the mole of that gas divided by the total number of moles. That we work out. Now let's look at some few examples. Now let's say we have the following question. A vessel contains the following gases. Gas A equals to 2 atm. The pressure. A vessel contains the following gases with partial pressure. Gas A equal to 2 atm. Gas B equal to 5 atm. Gas C equal to 1 atm. What is the total pressure of these gases? So as we have said, total pressure will be equal to the pressure of the first one plus the pressure of the second one, plus you get to the pressure of the last one, which is the third one. We have three of them now. We have just three. That what is the pressure of the first one? 2. The second one 5. The third one 1. So that will give us 8 atm. So this is their total pressure. 8 atm. So that is the total pressure of these gases. So it's as simple as that. Now let's look at another question so that you get it properly. Now let's look at this question. Now let's say a vessel has a total pressure. Of 500 atm. A vessel has a total pressure of 500 atm. If gas A has a partial pressure of 100 atm, and gas B has a partial pressure of 300 atm. What is the partial pressure of gas C? What will be the partial pressure of gas C? That is the question. A vessel has a total pressure of 500 atm. 500 atm. If gas A has a partial pressure, remember there's going to be total pressure means when you sum off all, if you sum up all the total partial pressure, you're going to have your total pressure. Now the pressure of individual gases inside the vessel is what we call the partial pressure. So please take note of that. So what they're asking is that what is the partial pressure of the gas C? Now remember we said total pressure will be equal to the partial pressure of A, the partial pressure of A plus partial pressure of B plus partial pressure of C. Now we are looking for the partial pressure of C. So what I'm going to do, we make that formula. We move this and this to this other side. So I'm going to have PT. If A crosses to this side, if this A crosses to this side, we turn to minus PA. If PB also crosses, we turn to minus PB. Then PC will be left here. So automatically, our PC will be PT minus PA minus PB. So this is the formula we're going to use now. Our PC will be PT minus PA minus PB. So let's go. Okay, we're going to have something very nice now. Remember PT, okay, we said PC will be equal to PT minus PA minus PB. So that will be PC is 500, PA is 100, PB is 300. So PC 500 minus 100, that is 400. 400 minus 300, that will be 100 atm. So that is the partial pressure of gas C. So please take note of that. It's very, very important. Now let's look at another example. Now the question we are going to look at now is a mixture of oxygen and hydrogen gas. A mixture of hydrogen and hydrogen gas has a total pressure of 1.5 atm. A mixture of oxygen and hydrogen gas has a total pressure of 1.5 atm, and the partial pressure of hydrogen, let's write it like this, P of hydrogen is 1 atm. Is 1 atm. Find the mole fraction of the oxygen gas. Find the mole fraction of the oxygen gas. Remember we said mole fraction is total pressure over the pressure of the gas divided by total pressure, or the mole of the gas divided by total number of moles. Now let's check if we can get that. So let's go. But we say we have what is not okay. First thing, let's calculate the pressure of the oxygen gas. The partial pressure of the oxygen gas. Remember, total pressure, it will be pressure of hydrogen plus pressure of oxygen. What will be pressure of oxygen? Move on to this side. We are going to have total pressure minus pressure of hydrogen. That will be 1.5 minus 1. So the partial pressure of oxygen is 0.5 atm. Now the next thing is to look for the mole fraction. Now the mole fraction, let's call it X, of this oxygen gas will be the partial pressure of the oxygen gas divided by the total pressure. That is 0.5 divided by 1.5. So that gives us 0.02. This is the mole fraction of the, there's no unit to, because it's the same thing dividing each other. The unit will cancel out of this oxygen gas. So this is how we calculate for mole fraction. So please, you can read more on this and be good. So let's go at the last question now. Let's go at the last question before we go. All right, let's look at this. A mixture of three gases give a total pressure of 860 millimeter Hg. Okay. If the pressure of the first gas, let's call this gas A, is 460 millimeter Hg, and the partial pressure of the second gas, let's call it gas B, is equals to 120 millimeter Hg, what is the partial pressure of the third gas? Let's call it gas C. Pause this video, solve this question, and see if you can get the answer. Pause the video, solve the question, and see if you can get the answer. All right, the answer is going to be as follows. Remember that our PT is PA plus PB plus PC, and so on. So to get PC, now we have saw something like this before. Now PC will now be equal to PT minus PA minus PB. So this is the formula we are going to use now to calculate and get the final answer. Remember, PC is unknown, PT is 860, PA is 460, then PB is 120. So let's look at the final question answer now. Our PC will be equal to our PT minus PA minus PB. That will be 860 minus 460 minus 120. What will that give to us? The answer will be 280 ATM. So please ensure you remember we have some gases that obey partial, that thing not for partial pressure dense, while some don't. For example, now let's say if you want to add sulfur dioxide and helium, they cannot react together. So a mixture of these two gases now will be that is for partial pressure. So mixtures do obey, but something that from a compound will not actually obey. That's how the thing is. So please just try and do more research and be good. Thank you. You can share and like this video. Also subscribe to the channel. God bless you.